Welcome to the new Rapidform webinar from 3D Systems. This time we have the topic Design Surfaces with Perfect Character Line Flow from 3D Scan Data. I'm Tobias Klein and Product Manager of Rapidform EMEA. So why should you use Rapidform? This is the first question. So some small facts about Rapidform as part of 3D Systems. 3D Systems is a leader in ideation to production with an experience of more than 10,000 licenses sold since 1998, since the developing of Rapidform. I'm sorry, this is live, you know. So, back. The innovation is Rapidform has 40 people in R&D, and we are inventor of modern scan-to-CAD methods with more than 30 patents for Rapidform. And our support has 30 in-house engineers dedicated to Rapidform customers. We have a technical center who does also Rapidform support and service, and more than 200 resellers certified to train and support Rapidform. The strength is that 3D Systems is listed at the New York Stock Exchange, the symbol BDE. We are already trusted by thousands of customers. Here's only a small selection of customer base for Rapidform. As we today want to talk about character line flow, then some sample customers, for example, are Toyota or Citroën, Audi, and so on. With Rapidform XOR, you can basically take any mesh creation device, such as an optical scanner, white light scanner, or laser scanner, or a tactile probing device which can capture dense point clouds, and we can mesh that to get a raw scan data. Or you can use computer tomography or whatever to get the raw mesh, and with this raw mesh in XOR we can create a parametric 3D CAD model. And this parametric 3D CAD model can be forwarded to your CAD software package, as is SolidWorks or Siemens NX, CATIA, Creo, Inventor, and so on, AutoCAD. So with Rapidform XOR, you have the fastest path to CAD. We are analyzing the scan data for primitives and for parametric structures, and we also have the opportunity to get freeform structures from the scan data and work hybridly to combine them and get a parametric 3D CAD model. Here we have an example, for example, for the shipbuilding industry. This was a long-range scan, and the purpose was to design a new top of this ship. So it was scanned, and in Rapidform we segmented the whole scan into several regions, which you can see here, the colored regions. And those colored regions have information about the geometry, and we just extract this information about the geometry and build parametric features for CAD. And we also extract freeform information, and we can combine this freeform and parametric features together to get this final product. To show you that it is literally no boundary how much freeform we can do, this is a case study from Ferrari, and it was also scanned by a long-range scanner, and as you can see here, from even incomplete scan data, there's some cleaning and editing, analyzing shapes and so on. And after intelligently constructing the mesh, the features are recognized, and we just patch surfaces on top of the mesh, and trim that surfaces with each other and get a surface model or get a solid model. Okay, to show you a live demonstration about it, I picked a smaller part because we don't have time for the whole car. I picked a part of cover, plastic cover. So I will show you. Basically, this is the result where we want to get. By the way, if you have questions, the chat panel is disabled. So if you have questions, you can put them in the question and answer panel. And after this live demonstration, there will be enough time to answer the questions. So basically, this is what we can get from this raw scan data. As you can see, the raw scan data has holes and it's also noisy. And yeah, we want to focus today on the freeform part. So basically, here we have two big freeform surfaces. And we have one difficulty always to get a nice character line between those two freeform surfaces as here. As you can see visually, this character line is quite nice. Molded or modeled in clay, or yeah, modeled already on a persistent part. And there's another character line around here. And we want to focus on those character lines and on the surface plan. I already prepared some basic shape, which is actually two extrusions and a fillet. So here we have an extrusion to this side, and here we have an extrusion to this side. This one is with a draft. You can see here this extrusion along this side has a draft of 10 degrees, and this extrusion as well has a draft of 10 degrees. And here we have the other extrusion. This is basically captured by using mesh sketch. We call it mesh sketch. This mesh sketch is actually cutting through the scan data at a specific point. And we can extract this shape of this sketch, and then we can go into the mesh sketch and just define our dimensions which we need. And we have the accuracy analyzer here. This accuracy analyzer at any time shows us the deviation between the section through the scan and the current design intent. So in this case, I've set up some dimensions, and I'm a little bit deviating from the scan data. But this, in this case, is necessary because we want to design something. So for design, we need to bring in some design intent. And the part which we scanned can already be deformed by gravity or by cooling processes or by some already wear and tear. So we want to exclude that error, and we want to design a nominal part in this case. So it's always helpful to have this accuracy analyzer here. The accuracy analyzer is available at any time. That means also in 3D you can see the accuracy analyzer colors. We can give a specific tolerance, let's say 0.5 millimeter plus minus, and then you can see we're overly in the green area, so it means we have we are inside the tolerance. Okay, so this is just the side, and if we look at the side through that surface, I can switch on the transparency, then we can see here our character line. And just visually, the character line looks quite straight in this case. So we could just assume that it is planar, that it is on a planar surface. So what I would do is just cut this down to this planar surface and start the surface from here. And on the other side, we look on the top of the freeform surface, and we can see that this is somehow curved around here. This character line is some curved somehow around here, and in between we have a blend or a fillet area, which is probably fillet in fillets, so multiple fillets here. And to define that nicely, I'm using just a normal sketch on the top plane. So I can just move that, on the front plane. I can just move that front plane up to, let's say, 100 millimeter. And then I'm looking from that plane, and I can do a normal sketch. In this case, I'm doing just a normal sketch, and then I'm just drawing on top of that scan data, just drawing my line down here. Because now in this stage I'm just defining something, just the character line flow. So in this case, again, I'm just defining my character line flow, and I'm giving it fillet. So this is a nice character line. Can extend that to the sides, so we can get out of the model first. And now with this, we will use this as a construction line, and we will use an offset to both sides. Let's say 5 millimeter to the front and back. So we have here 5 millimeter to the front and back. So this will be our top design line, and then on the side we will have another design line around here. So we can think of this plane as our cutting plane. Perhaps I'm moving it a little bit lower, 1.5 millimeter maybe, down here. And then I can use this to trim this surface, or split this surface actually. Split this surface at this plane using an intersection from here, and split those surfaces. Okay, so split this surface as well. Split those surfaces. So now we have, let's hide the planes here. Now we have a really nice line around here, and we have a nice line around here, but this line is not yet on the mesh. So how do we get that on the mesh? We actually have a possibility to calculate the regions. That's what I showed before in the PowerPoint slide. We have a possibility to calculate the regions based on the curvature information. So on this mesh, I already pre-calculated the regions. As you can see here, if I move my mouse over those regions, I have a revolution around here, I have a revolution, and I have a cylinder here, I have a torus here, maybe a plane here, and so on. So based on the region color now, I can detect what is what. So in this case we have cylinder and plane, so I made an extrusion. Here we have a cylinder and a plane, so I made an extrusion as well. So in this case we have several areas detected just as a revolution, so it's not very easy to just get a sketch and then just extrude or rotate it. In this case, we will have some freeform information, and I will make that using a so-called mesh fit. We have a mesh fit surface here. So on this mesh fit surface, I just select several surfaces. Several regions in the mesh. So just select this one here, and I'm looking from the side, from here, a little bit arranging my surface to the coordinate system. This blue square is basically a draping start, an initial guess how the surface will be fitted to that region. So I'm just defining my orientation, and then I can define how the surface is fitted. So I can tell based on the allowable deviation, So I can give, for example, 0.1 millimeter allowable deviation. Then the surface is really tight fit to the mesh. But we will also get every bump and dimple. So we don't want that because we want to have design surfaces. In this case, I can say I want to fit the surface by number of control points. Then I can give the number of control points per U or V axis. And I can go to the preview, and now I can see this is the deviation in this case, and I can see the isolines in this case, isolines flowing the surface. I can see the environment mapping. So if that is a little bit too bumpy for me, then I can go back and I can reduce the number of control points to, let's say, 5 by 5. Now it's less bumpy. We have, of course, we have less isolines, and of course we have a little bit more deviation in this case. So this is just the mesh fit surface to get quite quickly a surface from the mesh, which we can use in this process. So this is surface number 1. Same thing can be done for the surface number 2. The mesh fit surface. Again, here I'm adjusting my initial guess plane. So then let's see, isolines and deviation. It's a little bit more deviation, but a little bit smoother, as you can see here. So, and the third mesh fit around here. In this case, again, I'm adjusting adjusting to this, and then let's see the deviation and the isoline and the environment mapping. In this case, we have some upward bending, so I need to give some more control points in this case to reflect that bending, so the deviation is not so big. Okay, so 7 by 7, and then accept. And now let's see our mesh fit surfaces, how we get them together. So we have another surface around here. And now we can see the surfaces intersect almost completely, except in this lower area. So this area is our blend area, which is actually curvature based fillet from here to there. And I want to get the trim line around here and around here very nicely. So I'm just intersecting the surfaces first to get the trim line, and then a little bit lower or a little bit higher I will cut the surface. So this is my outer surface, and I will create an offset in that outer surface inward. Maybe some millimeters, let's say 4 millimeters or 5 millimeters inward. Okay, so 5 millimeters inward. Okay, now I can split my freeform surfaces using this surface, using the intersection tool. This one first, and same thing on the other side, so I can use this again. This one. Okay, and now I have a point here and a point here. This is where our blend surface ends. This is where our blend surface ends. So from here to there. And the same thing I can do up here because I made my previous sketch here. So I can use that top sketch to cut this top surface, to split that top surface. Let's do let's do a splitting by projection. So I'm splitting this one here. Getting an extrusion down from that surface to be able to cut it. So trim with my tool. This is my tool and this one is my target. So I have this one. And the same thing again, extrude. And now I can use that cutting function again to cut this one and this one. Okay, now you might already see where this goes. We have that freeform surface patch here, we have that here, and we have that here, and in between we have a very nice equidistant trim line. So in this case we just need the same thing in the middle. So I'm going back to my sketch here and getting my surfaces here. Okay. And now I can use a 3D sketch from point to point. So here I grab this point and here I grab this point which was previously created in this case. And again here I can grab this point and this point which was created previously. Now let's see our model which we did before, which was segmented before. Here we have a segment in the middle. And I will cut out this segment and then I will make blend surface around this segment. So this will be projected using a little bit more number of control points, a bit more freedom to be projected to that surface to be able to trim it later. So this curve will be projected here and this curve will be projected here on this feature. Okay, and now let's delete this and this, and let's split using that tool entity, this one, and same thing using that tool entity, split this one, delete those. And delete those. Okay, now I just need to close this gap here using a loft surface from there to there. I'm using the curvature to the face and I'm adding the side curve influence to be able to have a curvature continuous blend over this face. So it looks already neat. And then we will do the remaining blends. So now, again, check the deviation. In this case, we don't have a good deviation, so we could introduce one or two more lines to be able to blend, or we could introduce one or two more guide curves here and there. This can be done later, but for now we just leave it at that. So the next step is I want to trim all those curves, all those surfaces to the same boundary, or at least probably the same boundary, so that we can make a nice blend around there. And again, I'm using my top sketch, my top plane. What is it? There. Just doing a sketch, and want to see my scan data. So now from this point, I could convert this line probably, just using this line up to here. Just roughly. So from here to there, from there to there, from there to there. This is now integrating the design intent into this. So I'm just designing this outline around here. So now it is just a sketch high above the surface. We will just use the extrusion again to go down into the model. Okay, and then we trim using this extrusion. Trim with this one and this one. We want to trim this one and this one. And we want to keep this one, this one. Okay, I missed something here, but that is not a problem because it's just parametric. I can just go back to that sketch. I can just take this line and extend it a little bit and redo the trim in this case, because I want to keep this body. So now this one is trimmed. Okay. Now I can see on this side we have, from this side we have perfect blend, and in this side we still need to get the offset from here, need to get the perfect blend around here. So let's do this one first. This is just the surface loft from here to there, using tangency to face or curvature to face. And here we can define how much curvature we need, or how much tangency we need. Let's do tangency, and let's do this with all the others, with this one as well. And with this one as well. Now we have two possibilities. We can do it this way or the other way. Here we have guide curves around here. So this guide curve can be taken, and this guide curve. So we have a quite nice character line flow around here. So now this does not look really perfect now. So that's why I made the sketch before. So we have this sketch above here, and with this sketch I can now manipulate my design my character line flow. So I just double click the sketch, and I can just give some dimensions or some radius. Let's define some points. So now this is fixed. And now I can define a width for construction line from point to point. And I can define the width of this. Now let's say we want to have it 15 millimeter instead of 10. Okay, so then it will be 15 millimeter instead of 10. And it's much better to follow it, to follow the flow. So the same thing can be done here. You can do it this way, several in one go. Do it tangency in this case. 1, 2. Now here we have the problem that we get thinner in this case. So let's see how we handle that. Well, in this case, we could just offset that line up to here, so we could use our plane, move it upward, and then cut this by plane, and then we get an equidistant, a nice equidistant character line flow around here. So we use this plane down here, and just move it up, let's say 10 millimeter. Okay, and then at this 10 millimeter point, we will just cut our surface. Using that plane, cut this one, then keep this one, and now in this area it's a little bit tricky. So we could also use a freeform viewpoint. So we could use a viewpoint from that side and generate a plane based on view direction. So let's just look at this situation just from here. And then let's have a sketch on that plane, on that last one. Okay, and then let's have, for example, this one as a sketching line. I can just convert this edge to sketching line, make it as a construction geometry, then get my tangent circle here. And then from that tangent circle, I can just get an offset to one side, to this side, for example. And then just move this. Come on, make it coincidence. Move that back to here and get tangent circle to here. And then we can say, okay, this is the same length as this one. This one and this one equal length. Okay, and with this lines, I can just cut this upper line using tool and target, and then just delete this one. Okay, now it is almost equal in distance. Okay, and now we can use the blend feature, tangency to face, and here we can define the tangent length, same happens here. Tangency to face, okay, and in between. Tangency, guide curve here and guide curve there. Okay, so we need to do that first. And then we can use that loft surface using a tangency here and using a tangency there. Okay, doing again. And that's it. So we created this design surface, and now we can, basically go on with the remaining part. So, for example, here we can again create the sketch and extrude something from the top level, or create this hole again as extrusion, or create this cone, for example, as a primitive. So I can just use that solid primitive, for example, extract a specific shape. So I can say this is a cone until, okay, here's a sphere, so I want to have this cone. It's there. And then I want to have a sphere on the bottom. So let's see that sphere. Cut it out. So we have that sphere at the bottom. And then I can delete this face. And we don't separate solids and surfaces. So whenever I open a solid, I have automatically a surface. So in this case, it's just trimming this one with this one. Now the target, go to the next step, and then I have the surface. Okay, so that was the quick walkthrough through character line design based on 2D sketch for 3D freeform surfaces. And I hope this helped you in your reverse engineering task. Thank you for your time. Now we have time to go through the questions. Okay, we have some questions. what would happen if you extend those surfaces and trim them to a sharp edge and then apply the fillet. Okay, we can simulate that. So let me just simulate this situation. I'm just going back before everything happened. Just going back before this one. And I'm just simulating now trimming and filleting. So basically, trimming can be done face by face, but in this case we have a difficulty because we have three faces which need to be trimmed to each other. So in this case I need to select those three faces. Okay, and now the difficulty is how to get this edge around here and in the correct distance, the correct amount. So we have the opportunity to get a face fillet around here with two hold lines. So we can have one hold line here and one hold line here. We have to define the hold line. So let's see this hold line principle. I will use a 3D sketch and I will use a spline. And I will pick this spline here on the sharp edge which I created before. And I will move this spline down to here somewhere. I need to hide this one. So again, pick this spline at this position and go down to here somewhere. So I'm just basically following this region change. So between those two regions there is something happening in the curvature, so I will split those faces around here. And the same thing is happening around here, so I will use that edge and go down to here to split the complete surface. Now I have two lines but using only 2 points, and I need to project them onto the surface. So I need to increase the points, let's say to 5 points, and project the planes to that target entity, to project the lines to the target entity. So the lines are projected here. And now I need the fillet around here, so I need to 3D curve as well, from this point to this point. And this curve must be bent to this line and to this line, so tangent to this line and tangent to this line. Okay, so now I have the tangency here and I have something to cut out. And I will do that using the split face and using this tool entity and then choosing the target entities. And then I can delete those faces in the middle. So that will be perfect for blending this surface first. So doing the blend from there to there, I need another guideline from here to there, so I need to trim away that surface as well. So I need another 3D sketch which goes from there to there. So here we have another function which is called UV lines. I can define the UV line around here, for example. Delete that one, which I don't need, and go from that UV line to that point. Then make it here tangent, and make it here tangent. That was the wrong direction, so this direction. Make it tangent to here. Okay, so then I can use this line to trim, and the other line to as a guideline. So this is the trim line, filling this face and then doing the loft from here to there. From there to there, using this guide curve and using the other guide curve here. And now I want to see how this fits. Yeah, this fits pretty well. We should use tangency around here. We should use tangency around here. And sometimes it's possible to add a side curve influence if the surfaces are not too wildly bended or stretched. In this case, we use guide curves. So that would be the first thing, and then we need to sew it. And the next thing would be filleting. But as you can see here, yeah, the fillet is not nice because it is always difficult if you have raw scan data, and the raw scan data is noisy and bumpy to fit nice surfaces. So even though you don't have nice surfaces in the way I showed before, you get a nice character line, and this is what we want to do. In this case, I don't get a very nice character line if I just follow this line. To show you, we have several fillets, that is constant filleting. So I can just choose the fillet, and I can just click the magic wand button, and it's calculating something based on sampling. So I will check 25 maybe. And as you can see here, the fillet itself changes because the angle between the elements change. So the fillet gets bigger or smaller. To overcome that, we have a variable fillet. So we could say here is a variable fillet of, let's say, 20 to, let's say, only 10. Then we could define approximately the same radius around here. And maybe here from 20, let's say, to maybe 15, something like that. Or let's say, so maybe 30. So that would be the variable fillet. But we have a face fillet here as well. And the face fillet can just span from one face to another face. And I can define a constant width. So with that constant width, we get also a very nice equidistant line, but it still follows the edge of the surface. So I can define the width, 15 or 10. You can also define constant curvature if necessary. So that would be a good alternative if the initial surface fitting is quite good. And the other alternative is, let's roll back that. The other alternative is to project this sketches down. So in this case, I can just use the split face, project this one down to here. Again, split face, project this one down to here. Okay, in this case, it does not intersect completely, so I will edit the sketch a little bit. So basically, this radius is a little bit too big, so let's have it a little bit smaller. And let's see that it intersects with everything. So again, split face, tool entity is this one, and target entity is this one. Now it intersects with everything. And if I hide this one, then you can see we have this nice flow, and I can just use the face fillet. I can just use the face fillet, and then we have the possibility to use fold lines. So this is my face fillet, and I give a number, let's say 50 for the fillet, and now I can define hold lines. So this is my first hold line, and this is my second hold line. And now I need to increase the value, 60, 80, 100, and so on, 200. But somehow around this edge, the 200 radius will not bend around this edge very well. So this is the reason why we don't use that hold lines. So here we have it asymmetric, let's see that. So until here it works, let's say 75, 50. Yeah, somewhere here it stops because it bends too much around the edge. Okay, so that is why we don't use the fillet around here. We use the blend surface around here. This is the reason. So split face is okay, and then just remove those faces, and then just use the loft as a blend surface from here to there, and maybe curvature to face. Okay, same thing again, curvature to face. Okay, and same thing again, curvature to face. Now here we have another segment because our manually designed fillet is a little bit bigger than a little bit smaller than the other fillets. So in this case, curvature to face. Let's do it tangent to face in this case. And now we can use hold lines. Not yet. Sewing first. So roll back and then sew. This one. Okay. And then roll forward and do the dot. Now we can use the guide first. Okay. Here's some small tangency and using guide curves. So that would be the sewing, and with the sewing I can say I want to have this patched in tangency and with all other adjacent faces. Okay, so more questions? Okay, there is a question. When you live transfer to SolidWorks or Creo, are the mesh fit surfaces editable? Actually, mesh fit surfaces are not editable, but we have the possibility to do the same stuff as a loft surface. So we don't need to use mesh fit surfaces. I will just briefly show that. We can just go to the surface, and then I just define I want to have a loft surface. We have a loft wizard here, and that loft wizard is basically the same as a mesh fit from the handling. Just define some draping area and just define the draping direction, maybe something like that, from where to where the surface should go. And then by allowable deviation or by number of sections, let's say I want to have 5 sections only. And I want to have reference planes and mesh sketches. So it will be 2D planes and sketches, and they are transferable later to Creo or so by plane. Now it's calculating, and I can accept that. And this is the loft surface. So the loft surface, as well as the mesh fit surface, is fully controllable in quality and accuracy. So I can control the quality. So let's see, it's a little bit bumpy here. So I can go to this sketch, and here I have spline basically. So that spline has 100 control points, and I can say I want to have only 3 control points evenly spaced. Then it's recreating my spline with 3 control points. In this case as well, 3 control points evenly spaced. And as you can see here, I'm basically flattening or getting the best out of this surface. So this is almost a CAD surface with this isoline flow. Of course, okay, here is a little bit deviation because I choose too few control points, too few lines around here. So, but it's really CAD. And I can also use that and extend it like a CAD surface. No problem. Okay, next question. Okay, the question, how come you didn't use a sweep or lofted surface instead of a mesh fit? Okay, basically there's always the decision, what is the later the surface for? Is it for just manufacturing or is it for design? In this case, we want to focus on the design lines, and design lines is also important, for example, for the molding. But for the molding, the surface itself does not necessarily need to follow the UV coordinate system. It just needs to follow the surface quite well. And we have to consider at the first what we want to do. So we want to do a car body or something. Then of course we have to use loft or sweep or even other surfaces. If we want to use something like molding, then the surface itself is not important. Just the surface accuracy is important, and the isoline and the character line flow is important. So that's the reason why we use mesh fit, because it's much faster than designing a loft. Okay, how to make the letters on the surface. So the letters on the surface is quite easy. So if we just have that, let's say we have that surface, and then we look at the letters from a certain point where we can see them. We can also define the point by just extracting a plane from the letters. So for example, I just select here this, and this, some letters. So with that we will extract, come on, throw away, okay. With that we will extract a plane. So on this plane I can now sketch my letters. So defining the text somewhere here. Supercharged. And I can define the size and everything, and even the font. So this is Arial, but I can also define this should be, let's say, Arial rounded, because I want to mill it later. So now I have it Arial rounded. And I can also say I want to have it along a curve. It's also possible. So here I have that text. And then I can use a extrusion, for example, a solid extrusion in this case. Middle plane, for example, 5 millimeter. I just need to check that my extrusion is going through the other side. So let's say 10 millimeter. So that would be the solid. And now I can cut it out, and then I have the holes in the surface, or I can use the sketch to create an emboss This is also possible. So we can also use an emboss head or pocket. In this case I choose a pocket and I'm choosing my profile. I'm choosing my target. So this is my target. This is my target. And then the end cap surface is an offset of this target or a translation or something else. So I can choose another surface as well. And the side walls are normal to the face or normal to the profile direction or direction vector or whatever. And I can also use a draft of some degree. So in this case, just let's do it at 1 millimeter depth. So there is the text. And now I can apply fillet and everything else. So another question is, will you be showing how to do that groove that's cut around the supercharged text? Okay, why not? Then we can go ahead using that groove. So basically it's just the same. I'm using this plane, and from that plane I can just make a sketch, and then I just need to design what I want to see. So in this case, let's do just a line. I can zoom in very closely and create it very nicely. So let's see if that is horizontal or maybe not completely horizontal, as you can see. So going to here and going to there, somewhere in the middle of it. Then doing a 3-point arc from there to there, maybe. A little bit up to here, then doing a tangent arc from there to there, maybe. And doing a fillet from there to there. And the same time doing a tangent arc from there to there. 3-point arc and the tangent arc from there to there. So tangent arc. Okay, and here again. So now we have this, and now I can just a little bit extend to here. Then I would go and extrude this as a surface. Extrude it down through the body. Okay. And then I would use the thicken method because we have some thickness around here. So thicken that last body about both directions, maybe 1 millimeter. So it's 2 millimeters thick. Okay, so we have that solid now. And using that solid, I could use an offset of the previous surface. Using an offset surface, or I could trim it with that solid. It's also possible. We are just using an offset surface from that one, and that one. Downward, maybe 5 millimeter. Okay. and then I'm just cutting with this offset surface this solid. Okay, it doesn't come through wholly, so I will let's just see. I need to offset the other part as well, so get that offset around here as well. This one and this one, and extend here. Extend here. And here. And then cut using this surface, cut this target body, and keep the other one. So, and now the tricky thing is we want to have a solid surface operation, so I need to make a surface from that solid. All I need to do is just delete some faces. Then I have a solid, then I have a surface. So delete this face and this face on the top, and this face here. So now I have a surface operation, and now I can use the trim tool to trim this and this. And go to the next step, and then I can keep this one and the small one beneath. And of course the inner part. And of course the inner part. Okay, that's it. Okay, so there are still some questions left. Regarding the pipe wizard, the question, could you use the pipe wizard on the original character line, then offset the OD of the pipe and use it to trim your surfaces? What is the OD actually? The pipe wizard is working if you have more than 180 degree of the pipe. If you have less than 180 degree, then the pipe wizard is not the best choice, because it cannot really detect the circle center of the section of the pipe. So the radius can vary, and that is also what we don't want to have if we want equidistant lines. But there is another opportunity which can be done. Let's investigate this one. So we have roll back to here. Now roll back a little bit more. This was a loft. This was the Sioux. Roll back to here. Roll back to here. There would be a possibility to just make a section around the virtual sharp edge, so to speak. Yeah, so I can design on the mesh. I can design my virtual sharp edge manually, or I can let it calculate by the program. However, the virtual sharp edge depends on the noise of the part. So if I have many noise on the part, then the virtual sharp edge doesn't look really good. So what is possible? I can do a 3D sketch, for example, do it directly on the part. And I can extend it. Okay. Extend it. Extend it. So then we have the possibility to choose a plane perpendicular to the curve by n division. So I can tell n division and offset and then choose the plane, and I can modify this plane, let's say 100 offset, and on this plane I could do a mesh sketch with the fillet radius. However, if the angle between the fillet changes somehow and the fillet is the same, then the fillet width will change. But if we want to keep the fillet width the same, then we need to do it this way. Just define a fillet width and let it run along our spline. So define this one as piercing constraint to this one, and then define the fillet width with, let's say, 2 millimeters, and not this fillet itself. So with that 2 millimeters. And then I can say I have this surface here, and I can sweep, for example, this path around this one, and then trim with this path. However, it also needs to follow this line, so I need to make the fillet width bigger, that this path is inside. So let's say 7.5. It's quite big. So 7.5. Now this one is inside. And now I can use trimming again, and then I can use the loft feature again. So I want to keep this and this. This is also a interesting way, a quick way to do an equidistant. And in this case, I can use the complete path and make it tangency to the face or curvature to the face, like this. Tangency to the face in this case. However, I need some guide curves in this case. Okay, there are multiple more questions. The time is limited, so we cannot answer all the questions. I hope that helped you a little bit with the reverse engineering task, and I hope you will follow the next webinar. In May we have the control show, so in May will be no webinar, but you are invited to the control show, and in June there will be the next webinar. We will record this webinar and publish it on our website. So you can see here, the link is www.rapidform.com about us webinars, and you can find the past webinar from last month as well, which was about scan to print, design your own phone cover, and you can see several similar aspects of the modeling in that webinar as well. Okay, thank you for attending.